Hello everyone. In this video, I'm going to walk through an example of creating a Visual Basic program that will calculate a variance covariance matrix for you. And as an example, I'm going to pull up the stock prices for two different companies, and then we're going to calculate the returns for the monthly returns for those two different companies, and then we'll use our program that we're going to create to calculate a variance covariance matrix of the returns of the two companies. So let's start off with the first part there of actually just pulling up some stock prices for companies. For this, I'm going to use the Excel function stock history, and for that to work, you need to have the tickers of two companies and then the beginning date and the end date for when you want the stock prices. So we're going to choose two companies that don't pay dividends. The information provided in the stock history function does not adjust for dividends. So we want to have two companies in this case, for this example, that don't pay dividends. So I'm going to choose Amazon and Tesla as our two companies that in the past 3 years haven't paid dividends. So my two companies are Amazon and Tesla, and their tickers are AMZN and TSLA respectively. And we're going to use 3 years worth of information here. So I'm going to start January 1st, 2021 and go through January 1st, 2024. And now I'm going to use the stock history function to pull up the prices of Amazon and Tesla for these dates. So here I'm going to put stock history. The first variable is the stock, then comma the start date, comma the end date, and then the interval. Daily is 0, weekly is 1, and monthly is 2. I want to get monthly stock prices. So it's going to pull that up for Amazon. Now we're going to do the same thing for Tesla here. Stock history. Highlight the ticker, highlight our first date, highlight our last date, and then put in 2 for monthly and get our answers there. So now we're going to calculate the returns for Amazon and for Tesla. So now I'm going to calculate the returns by taking the natural log equals ln, the price after a month divided by the beginning price. So the price on February 1st, 2021 divided by the price on January 1st, 2021, and then close the parentheses. And for Amazon, it was 3.6%. I'm going to do the same thing here for Tesla. I'm going to put in equals natural log, the price on February 1st, 2021 divided by the price on January 1st, 2021. And we actually, they had a bad month there. Tesla had a month where the return was negative 16%. So now I'm going to highlight these two. I'm going to drag it down to the next to last value for the prices. And that's because if we pulled it down one more, we would get an error term there. We can see just by kind of eyeballing this a little bit, Tesla is a fairly volatile stock, and we're going to, this is going to show up as we do our calculations as well. So now that I've got my returns, I'm going to go out to developer and start to program or start to write my program. First, before I do that though, I want to show you how to save this as a macro-enabled workbook. And then if you don't have the developer tab up here, I'm going to show you how to add that. So let's go out here first. I'm going to go to File and then Save As. And I am going to go to where I want to save things at. So I'm saving mine in a notebook called Financial Modeling. And I'm going to name this workbook, just so I remember why I'm doing this, VAR, COVAR, for variance, covariance. And then down here, save as type, I want a macro-enabled workbook. Then I'm going to go out here to File and then Options. And to put developer in your ribbon there, you want to go to Customize Ribbon and scroll down here on the right hand side. If developer is not checked, you want to check developer. Okay. Then press OK. Now we're going to go to developer and then select Visual Basic. And then you want to make sure, if you have other workbooks open, you want to find the one that you want to add your Visual Basic program to. So mine's var. And then I'm going to highlight that. Then I'm going to go up to Insert and then Module. And we're going to type our function into the module here. And I'm creating a function called var for variance covariance matrix. I'm taking this out of the textbook Financial Modeling by Simon Beninga, the 5th edition. I do make one small change to the program because there's a line in there. It creates a variable that's not used, so we're not going to include that line. But we're going to start here with naming our function. So we're going to call it function var. And then in parentheses, RNG as range. What we're doing there is we're saying that there's going to be a range. We're referencing that range as RNG, which is a range object. And then we're going to put in as variant. And variant is a generic data type. It can store different types of values, including arrays, and in this case is going to be an array that is the output of this this function that we're creating. When I'm done with that, I'm going to press enter. And when I did that, you see it says end function. So I didn't type that in. That's something that is created whenever you begin creating the function. We're going to create 3 variables. We're declaring 3 different variables here. The first is I, the second is j, and then the third is one called numcols, or numcols. So we're going to put in here dim I as integer, and dim j as integer. And what we're doing here is we're creating these 2 variables that are integers. They start at 1 and then go 1, 2, 3, 4, 5 to the number of counters that we need. And I'll show you this as we get to it. And we use these in a loop to calculate all of our covariances and our variances for our different variables. The last variable we're going to create here or declare is one called numcols, numcols, and this is going to be the number of columns. So in the case that we're looking at with the 2 stocks, the number of columns will be 2 because there's 2 variables that we're looking at. We can make this as large as we need to get as many variables and as large a variance covariance matrix as we need. The numcols is an integer that will store the number of columns in the range RNG. So the next thing we're going to do is we're going to have the function count the number of columns. So we're going to put here numcols equals RNG columns dot count. This this sets the variable numCols to the number of columns in the range RNG by counting the columns in the selected range. This is important because the function needs to create a square matrix with as many rows and columns as there are columns in RNG. The next thing we're going to put in is dim matrix, open parentheses, close parentheses, as double. So what this line does is it declares a two-dimensional array of a data type as a double. So the double data type it just allows complex numbers and is different than an integer because an integer is just a whole number. The size of our matrix will correspond to the number of the columns in the range that we've already created. The next line is redim matrix numCols -1, numCols not -1, this resizes the matrix to have the number of rows and columns be equal to the value that we got from counting the columns, the numCols. The -1 is used because arrays in VBA are zero index, meaning the first index starts at 0. The next line starts our loop. We have an inner loop and we have an outer loop because we have a matrix with two different dimensions. So we're going to put for I equals 1, 2 numCols, and again, numCols is the number of columns that we counted. So for our first example here, we have 2 columns. So I is going to be equal to from 1 to 2. And then our next loop will be for j equals 1, 2 numCols. So this ensures that the covariance is calculated only once for each pair of columns and that the matrix is symmetric, because covariance is what we refer to as being commutative. That means that the covariance of x comma y, x and y, is the same as the covariance of y and x. The next line calculates the covariance. So we're going to put in here matrix I minus 1 comma j minus 1 equals application dot worksheet function dot covariance underscore s. So what we're doing here is we're calling up the covariance.s function. Whenever you convert functions from or take functions from Excel worksheets and put them into Visual Basic Code, where we would have had a period before, where we would have put in covariance period or .s, that dot or that period becomes an underscore. So that's why that's here. What we're doing here in this first portion of the application.worksheet function is we're saying this is a function used in worksheets. So we're saying the covariance.s function is a function used in a worksheet, and that's what we're going to use here. Then we're going to put in open parentheses RNG dot columns, open parentheses I, close parentheses, comma, RNG dot columns, open parentheses j, and then 2 close parentheses, And so this calculates the sample covariance between the ith and the jth columns of the range using Excel's covariance s.s, or the sample covariance worksheet function. The result is stored in the matrix position I-1, J-1. And again, that's we have the -1 there because VBA arrays are 0 based. The next line is matrix J-1, comma I-1 is equal to matrix I-1, comma J-1. Since the covariance matrix is symmetric, the covariance calculated between columns I and J is also valid for columns J and I. So this is where we're taking a half of the variance covariance matrix and copying it over to the other half of it. And now we're going to end our loops. Next, here we go. Next J, and J is our inner loop. And then next I. These mark the end of the I and J loops, meaning that the covariance for all pairs of columns has been calculated and stored in that matrix that we created. Then finally, we're going to have our return statement, var covar, our function, is equal to our matrix. And this statement returns the matrix as the result of the function. And then, of course, we have at the end here end function. So let's go ahead and save that. Then I'm going to close this out. I'm going to go back out here. I'm going to create my variance covariance matrix, Amazon and Tesla. I'm going to highlight the area that I want my variance covariance matrix to be in. So I'm going to highlight that area. Then I'm going to go up here to my formula bar and put in equals var covar. And you can see as I'm typing it, it pulls it up here, var covar, open parentheses. So I'm going to highlight all my returns here, close parentheses, and then hold down Control, Shift, and Enter. And I get my variance covariance matrix. So I can double check this. Is this coming up with what I should have here? So I'm going to put in here v equals var.s, and then I'm going to highlight and then close parentheses, and I get the variance here, which is what I wanted. And then I'm going to put in here covariance.s. I'm going to highlight the returns. Oh, sorry. I'm going to highlight the returns for Amazon. And then I'm going to highlight the returns for Tesla. And then close parentheses. And I get 0.011691. So it accurately calculated the the variance for Amazon, the covariance for Tesla and Amazon, and then finally equals var.s, highlight Tesla, close parentheses, and I get the variance for Tesla. Okay, so that ends this video. Please let me know if you have any questions about it.